Good morning, everyone. So, first of all, welcome and thank you, all of you, for joining this session. Now, we will be demonstrating how geospatial technology is transforming the renewable energy landscape. So, the world is moving towards a future powered by clean renewable energy, right? So, this is not just an engineering challenge, it's deeply geographic one. As all of we know, the world races towards net zero goals. Hence, the renewable energy is no longer optional. It's an essential now. So, as we all know, unlike fossil fuels, which can be transported and stored, the renewable resources like sun and wind powers are tied to the specific locations only. This means the every decision from where we should place a solar panel to how to connect it to the existing grid is driven by the geography. So ArcGIS provides powerful platforms to connect this geographic data, turning complex problems into clear and actionable insights. It is the science of where applied to the future of energy. So, if I talk about the planning and assessment in this slide, so there are intricate challenges to implement the large-scale renewable energy projects in India, such as determining the most suitable locations and then addressing environmental impacts and ensuring compatibility and integration with existing infrastructure. This integration is very important. This is where ArcGIS comes in. It helps us visualize, analyze, and act on spatial data to make smarter and faster decisions. So here, the most critical factor for renewable projects success is selecting the right site. This is very, very, very important. This requires balancing dozens of variables. So ArcGIS allows us to perform a multi-criteria suitability analysis and then we can combine and analyze the multiple layers of data such as land use, solar radiation, wind speed, terrain, proximity to power grids, transport facilities, and environmental constraints to identify the optimal sites. Now, construction and development part. To mitigate construction and development challenge, especially in India, we can integrate ArcGIS with AutoCAD and BIM models to streamline the design and supports field crews with mobile apps, especially ISRI India have developed so many mobile apps for data collection and progress tracking with the help of ArcGIS field maps. The field maps is the flagship product of the ISRI India for especially mobile apps. Then if I go to operations and maintenance part, so ArcGIS helps in real-time monitoring of assets, predictive maintenance and fault analysis to maximize the energy output and reduce downtime. Here we can use ArcGIS dashboards, real-time dashboards for the real-time monitoring and utility network for asset management and tracking. So the key takeaway here is the ArcGIS plays a valuable role throughout the entire life cycle of renewable energy projects, from planning to innovation. So let's watch quick demos, which will be showcasing by my colleague Suraj. Over to you, Suraj.
So we will take a look at what's driving the global shift towards renewable energy. So at the center of this transition is a powerful combination of economic, environmental, and regulatory forces. First, on the policy and financial side, initiatives like the Inflation Reduction Act have created unprecedented certainty for growth through renewable production incentives and tax credits. So this has given organizations confidence to invest in the long term. There has been stakeholder pressure coming in from customers, investors, and even employees. So this is pushing companies to adopt cleaner and adapt more sustainable energy practices. Governments are also stepping up with stronger regulations and disclosure requirements, compelling industries to track and report their carbon footprint transparently. From a market perspective, we can see that the cost of technologies like solar and wind continues to fall rapidly. So while wind has traditionally led this market, solar is now expected to see much faster growth in the coming years. And we can't overlook energy security as well. So there is recent volatility in the fuel markets, which has highlighted the importance of diversifying energy sources to ensure that countries remain independent for energy production and distribution. And this has all led to looking for cleaner energy sources, which comes to renewable energy sources. So renewable energy is clean and reliable energy source that does not pose a threat to the climate as well. And when we look at the players in this scenario, in the scene, we have multiple players like oil and gas industries, utilities, IPPs, independent power producers, owners, developers, operators, EPC suppliers. And there is a prediction that by 2026, these oil and gas companies will dominate global renewable energy generation. So Raja explained a typical project life cycle, right? In a slide, we were able to see the different phases that happens in a renewable power generation project. So let us break it down into multiple phases and see what all relevant GIS use cases are there. And we'll take a look at demos for these individual phases. So first up is planning and assessment. So when you plan for a new renewable power generation project, the main the main concern would be finding an appropriate plot of land to set up your project, right? So here is where GIS site selection comes into picture. So ArcGIS provides site suitability tools that can take multiple parameters as input. So it can be your solar properties, it can be your wind energy properties, distance to the existing infrastructure, your topographic parameters like slope, aspect, right? All of these multiple parameters can be taken in, and also demography layers like your customer analytics, your population density can also be taken. And this multi-criteria analysis will give you a single output from which you can finalize your sites where you can install your projects. Moving on, we have development, design, and construction. So here, rightfully, we can tell that here is the phase where the initial level of planning happens in terms of design and construction. So there will be AutoCAD drawings like BWG files, DXF files, and also 3D models like Revit, IFC. So here we can integrate that directly with ArcGIS Pro. We have a direct connect with ACC, and we can import these files into ArcGIS Pro as well as ArcGIS Enterprise. So this helps in enabling planners to see a 3D visualization of their projects and also helps in planning digital twin representations. We can also have applications like dashboards and web apps that can be used for construction progress monitoring. And the 3D analytical capabilities in ArcGIS Pro as well as ArcGIS Enterprise enables designers to see the visual impact that is caused by these wind turbines or solar panels or any asset that they have. And land ownership management, land parcel management can also be done in this particular phase. And the final phase, once your project is up and running, to ensure that it has a reliable productivity, there should be a strong operations and maintenance. GIS plays a huge role in this particular phase. There are multiple use cases that ensure that the performance is improved, that the KPIs are met of these projects. We also have maintenance workflows and mobility solutions, which mostly center around mobile applications that can be used for asset inspections. These farms, both solar as well as wind, are generally large, and it will have a field crew that does day-to-day maintenance or routine inspections. So their traditional workflows can be converted into digital workflows where the input comes in from ArcGIS mobile applications and the output is seen directly instantaneously on a dashboard. So what are the technologies that support these use cases? So first and foremost should be spatial analytics. So any GIS tool that you use will come into spatial analytics. So calculating the solar potential through solar radiation tool sets, all of this will come in spatial analytics. AI/ML. So now ArcGIS supports deep learning workflows. We have pre-trained models called DLPKs and also tools that support DLPK workflows. As I told, digital twins that are made with 3D models, be it from BIM or be it native 3D models that are there in ArcGIS Pro itself, ArcGIS ecosystem itself. Your input layers will be your imagery layers that comes from remote sensing, aerial photographs, etc. And finally, integrations. So we can't deny integrations here. All these different projects will have multiple sensors capturing multiple parameters in real time or live. So ArcGIS provides a platform that can support multiple types of integration with APIs to multiple sensors, be it SCADA, be it IoT, be it weather sensors, temperature, etc. So a major concern that or a major roadblock that renewable energy projects have is a lack of data. Most companies or organizations spend lots of time to collect this data and collate this data. ArcGIS Living Atlas of the World is a data repository that is managed by S3, and S3 India has specific layers that are maintained by the S3 India data team. So let's take a look at ArcGIS Living Atlas of the World now. We will see what all content is there for renewable energy. So ArcGIS Living Atlas of the World can be browsed from your browser. You can go to this particular URL and you can browse the different data sets that are there. This won't require a login. So I'll quickly go to browse. And I'll change the region to India. So here I can see there are almost 659 layers that are there for India. And it comprises of multiple types of layers like feature services, map services, live streams, so traffic data, live stream grid data, web maps, etc. I will search for the keyword renewable, and we can see the different layers that are coming up. So the state-wise renewable energy target achievements for each state, updated 2024. The potential of wind energy at different heights, altitudes like 100 meters, 120 meters above ground, right? So there are multiple layers that are visible on my screen now. We'll take a look at one individual layer in a bit more detail. So this is a Solar Atlas web map that is there as part of our Living Atlas offering. So we can see a detailed description telling what the different parameters are that are captured, what can be done with this particular layer, the associated web maps if there are any, and also the metadata details like the resolution, the source type, pixel type, etc. We can also see the acknowledgements, and we can see from which trusted sources this data has been sourced. So we can see World Bank Group Energy Sector Management Assistance Program. So these layers or maps can be directly integrated into your workflows. We can directly open it in Map Viewer here, or I can take it to my ArcGIS Pro desktop software. Apart from these layers, there are also applications that are available in Living Atlas of the World. So applications like Air Quality Aware, Sentinel-2 Land Cover Explorer, which is there for the whole world, and other applications. We will take a look at a particular application called World Imagery Wayback. So this is a catalog of our base map imagery that we use, the imagery base map that is given through ArcGIS Pro, the desktop, as well as ArcGIS Enterprise. So this is a historic catalog of the whole imagery base map that is there in the world. Here we can search for any address or place using this search option, search button here. On my screen currently, I have opened a solar farm in Andhra, Kurnool district. And here the app also provides a swipe analysis. So I can see that there are these many versions with local changes. I will select 2018 on my right, and on my left I have 2025. So now using the swipe analysis, I can see how the solar farm has grown through the years, through 7 years, right? So we can see this is very high resolution imagery that is provided. And this dataset can also be downloaded. So there is a download option for each individual data layers, imagery datasets, and it can be exported as the imagery tile package. Once this is downloaded, you can utilize this imagery for your workflows. You can run deep learning models on top of it. Deep learning models or change detection models can be run on top of this. And this will ease your workflow. And this will give you a really good source of imagery datasets. let's go back to the presentation. So now we'll break down the whole uh, phases one by one, and the first would be planning and assessment. So in planning and assessment, we can mainly use ArcGIS Pro, the desktop software, to identify ideal locations, as we were telling. So site suitability would be one major workflow that can be achieved in this particular phase. And different parameters, as I told, slope, aspect, land use, proximity to the existing infra, all these can be taken in. Layers from the living atlas, which I just showcased now. So we have pan India elevation data, so which, and also the derivative products like slope, aspect, which can be readily infused into your workflows. Land cover data is also there for pan India 2025 from Sentinel-2 satellite, right? And all these different living atlas layers can also be taken in as inputs. And today we'll be taking a look at the solar radiation toolset, which is a part of the spatial analyst extension. So this can be used to calculate the global and direct radiation on surfaces once you provide a elevation raster as an input. So it can take the parameters like terrain, orientation, and time of the year into consideration while generating the output. So once we have all of these different inputs, we can combine them together into a suitability model, and we can do even a weighted overlay analysis where you can give individual weights to these input layers, and we can map the most viable zone area for solar as well as wind projects. So let's quickly jump to ArcGIS Pro now. So this is ArcGIS. So here I have a project up and running. So this is, we are trying to find the solar sites, suitable solar sites for the state of Rajasthan. So it's a large scale project that we are having here. So what you're currently seeing on the screen is the solar raster output that has been generated from this raster solar radiation tool. So before I show the tool, I'll show the solar radiation tool set. So there are multiple tools which can be used for your analysis. So for this particular study, we are using raster solar radiation. So here we'll input a digital elevation model, elevation raster, DEM, DSM. And we can also specify the date and time for which you want to simulate this particular output. Topographic parameters like slope and aspect also will have to be given as inputs, which can be generated using ArcGIS Pro itself. So once you run the tool, you will get an output which shows the kilowatt hour per square meter for each individual pixel. Apart from this, we are also taking multiple inputs like vector files, including the existing infrastructure like the substations, the roads, the railway lines, and transmission lines. So once we have this, we'll run the tool called weighted overlay analysis. And here we will be taking in the different inputs that we have selected. The vector files will have to be converted into a raster format. So for that, we use the tool Euclidean distance. And once the tool is run, so I'll just quickly show the input features as well. So here we can see the different vector files that are there. These have been converted into raster. And finally, we run the tool weighted overlay. So I'll quickly show the tool weighted overlay as well. So I have it already up and running here. So we have the different rasters given as inputs, and weightages have been assigned. So here, based on the importance, you have to give the weightages. The cumulative weightage should sum up to 100. And here we have given a higher weightage as the solar raster the radiation raster will be of more importance for this particular workflow. And this will generate a raster output where the pixel values are given ranks based on a scale 1 to 9 in this case. And that is converted into vector, into polygons, and we find the suitable sites. So we have again drilled down the data based on a criteria. We have taken areas that are 6 acres and above. This is to ensure optimal solar production generation. And we can see the finalized site. So we can select a site which is greater than 6 acres and which is generated by the tool, a polygon output. Right. We can also see that the tool has worked properly because it has selected sites where existing solar panels have already been installed. Now let's take a look at a smaller scale project. Say you want to find the rooftop estimation or rooftop potential, right? So here we have a high resolution DSM for a city in India. I also have the building footprints extracted. Once I run the same tool, I get the result of the solar radiation. And using some basic mathematics and the tool zonal statistics as table, I can append this data onto the building footprints. So this raster output which I generated can be taken into a vector format as a field. So I'll just show the tool that is used for this. It's a tool that is available with the image analyst extension, zonal statistics as a table. And once I run the tool, I get an output which has been classified based on the electric production in megawatts per hour. I'll quickly show the attribute table for the same. Here I can see that the usable solar radiation in megawatts per hour has been added for each of the individual buildings. So what we just saw is a offline workflow where I'm a GIS analyst who is working on the ArcGIS Pro desktop software. So if I want to share these results to my management or to the stakeholders, as this is a connected desktop, I can just share this layer into my ArcGIS Enterprise as a web layer. And I can utilize app builders like dashboard or better showcasing the results. So here we are seeing on the screen the same data that I just showed on ArcGIS Pro. So we have built a dashboard around it and we have given the statistic details as indicators. So the total building available, the total electricity megawatt per year, and a pie chart which shows the percentage based on generation potential. So I will quickly show how the filters can also be used. So I can filter out the buildings based on its generation capacity and also based on the roof type. So as I change my selection, we can see the indicators are also changing. It is showing the current buildings available for this particular selected roof type and also the total electricity potential megawatt per year. So the products used were ArcGIS Pro, Spatial Extension, Spatial Analysis Extension, ArcGIS Enterprise, and ArcGIS Dashboard. Moving on to the next phase, we have design and construction. So once you have your site selected, we'll have to map the assets that we are planning to build. We can map the assets both in 2D as well as 3D. So here we will be mapping assets such as different assets that take part in a renewable energy project like a solar panels, the wind turbines, the substations, the transmission lines, and so on. So we'll be also using 3D symbology that is out of the box available in ArcGIS Pro to visualize these wind turbines or solar panels and to understand the layout in general. We'll also be using 3D analytical capabilities on the web with which we can do analysis like shadow cast, visibility analysis, terrain analysis to understand how optimized the turbine placement is and also to understand the solar efficiency. And in this phase, as Raja had mentioned, we can integrate Revit and BIM models for building your digital twins or for a 3D detailed infrastructure 3D visualization. So let's jump on to the demo for this phase. So I have ArcGIS Pro again open up on my screen. So as a GIS analyst for a wind farm project, I've been given a data which is in a CSV format. I directly opened that CSV in ArcGIS Pro. And upon inspection, I am able to understand that the data is related to wind turbines. So I can see that there are different tower IDs. There are fields of projects, height, the tower type. There's a date field which has captured the installation date field, operation status, currently whether it's operation or under construction, and also the latitude and longitude. So as a GIS analyst who is utilizing ArcGIS Pro for GIS, we can directly plot these points with a click of a button. So there's a GP tool that plots these points from the CSV file into a feature class, point feature class. Once I plot it, I'm able to see the layout of my wind turbines and my wind farm. And as this is a time enabled data because there is a time field, I can also run a time slider animation to see how my wind farm has expanded through the years. So here we can see how every year there are more number of wind turbines added into my wind farm. Right? So let's take it a step ahead, a step further. So we are now visualizing the assets in 2D. So thanks to ArcGIS Pro's 3D animated symbology capabilities, we can see and visualize the same assets in 3D as well. ArcGIS Pro has multiple 3D symbology that is available with ArcGIS Pro. So there are different style packages with which you can enable 3D animated symbology, wind turbine being one of them. There are also 3D symbols for billboards, industrial, etc. And ArcGIS Pro also provides the flexibility to change the properties of the symbology, like the size, the angle, the halo, 3D behavior. We have also imported a custom symbol style for the solar panels. So these are point datasets, point feature classes, which are represented as solar panels here. And again, once I have mapped my assets in 3D, I will share them onto ArcGIS Enterprise, and we will take a look at how you can utilize ArcGIS Enterprise's 3D analytical capabilities for better planning. So here I have configured an Experience Builder application. So Experience Builder is out-of-the-box application available in ArcGIS Enterprise that lets you create experiences, web experiences. So here I am showcasing the 3D toolbox widget that is available with Experience Builder. So this is the same dataset which I just pushed to server from my ArcGIS Pro. So here in this case, this is a hybrid farm where two different types of renewable energy comes into picture, wind and solar together in a single piece of land. So while installing these devices during the planning phase, the architects and designers should know if there is a shadow cast that falls on the solar panels from the wind turbines. So ArcGIS Pro provides shadow analysis. ArcGIS Enterprise Experience Builder provides shadow analysis, sorry for that. And we can see that once I run the animation for a selected date, I am able to see the shadows and how it affects the assets. Apart from this, there is a shadow cast tool as well. So here it will show the shadows which are projected by the assets, and it will also show the duration of the shadows. So once I click on the shadows, it will show me the time, the duration of the total shadow time in hours for each of these assets. We can also have line of sight analysis where we can draw lines of sight from any point in your 3D scene. And if it's green, it means there is a direct visibility. If it's red, there is no direct visibility. So these are the different types of analysis that can be done, 3D analytical capabilities that are there on ArcGIS Pro as well as ArcGIS Enterprise, which can be utilized by designers in the design and planning phase or construction phase to understand how the dynamics of the asset and how it will interact with the environment. Going back to the final phase, which is operations and maintenance. So this is the major phase where you have different kinds of integrations from different systems. So here again, we can utilize ArcGIS applications like dashboards and experience builder to monitor the real-time performance of assets, which is basically taking in parameters coming in from these different systems like SCADA, weather sensors, your live feeds like IoT, CCTVs.
Suraj, before you go into that, there's one question. Can I get a shadow map over the entire year for a particular object? This was from the previous demo, I think.
Yeah. So that can be generated. Yes.
Okay.
Yep. Yes. Sure. Can I go ahead?
Yes, please.
Yeah. So again, as I was telling, so these are parameters that are being fetched from SCADA systems, weather sensors, and other IoT devices, right? All these different live feeds, which will give you a live situational awareness. Apart from this, if you can see the video that is being played on the left, we also provide mobile applications like field maps and survey 123 for collecting inspection data, photos, geotagged photos, videos from the field, and also for navigation. So if you want to navigate to a particular solar panel based on the asset ID, we can also do routing solutions using these applications on a mobile or a tablet. And the beauty of this is a service-based architecture, and all of these updates that are being collected from the field are synchronized instantly with the enterprise server and are reflected instantly on dashboards and the final end applications that are being utilized by the office staff. So this ensures that there is a faster issue resolution and also there is quicker compliance tracking. So the products again that I'll be talking about, how the demos will be revolving around these products: Pro, Enterprise, Experience Builder, Story Maps, Field Maps, the mobile application Field Map and Survey 123, and also ArcGIS Velocity. We'll take a look at how these products are used for the demos. So here I have a dashboard which showcases 3D data of a wind farm. So apart from the traditional assets that comes into play for wind, we also have different electrical assets that helps in transmitting the collected energy into the distribution tier. So we have different electrical devices like isolators, circuit breakers, power transformers, voltage transformers also. And these are dynamic in nature, these indicators. Based on the current map extent, they get updated. We can also filter out based on a substation and also the asset type. This dashboard is linked to a survey form, which I have attached here. So ideally, this survey will be accessed by the field crew or the field staff from their mobile or tablet devices. So it allows the field staff to do maintenance surveys. So all these different fields are captured: the asset unique ID, name of the asset, name of the substation, name of inspector, the current condition, which is a list option, maintenance, whether it's due or not, and also the date and time is auto captured. And also the field staff can upload geotagged images or videos directly from the field. So if they find that there is an issue with a particular asset, they can click a photo of the asset, they can record a video, they can upload from the directly from the gallery, or they can also have a live camera, like live photo taken. There is also signature option where we can have a e-signature captured for verification. So here on the right, the office personnel will be seeing the data being captured from the field as a list. So the name of the asset, the current condition, maintenance view. So the list is designed in a way that all these different parameters inspected by which person at what time, all these are available as a list. So these are all cross filtering. Once I click on this, that particular asset will be selected on the web scene and they'll be able to see the attachments that have been uploaded through the survey form as well. Let's move on to Story Map. So Story Map is another interesting out-of-the-box application that is available in ArcGIS Enterprise. So Story Map allows you to publish your work as an article, as a geo article or a story. So this can have different maps with beautiful cartography and also the applications like dashboards, experience builders embedded onto these story maps. So this can be created to spread awareness within organization, or this can also be public facing story maps to spread awareness within or in the public sector as well. So here we have a story map for land suitability, site suitability for wind energy infrastructure. So we can see that the different maps. So Gujarat is an area of interest here because there is a favorable terrain and consistent wind patterns. So different layers are again taken here, just like the solar site suitability. So low elevation coastal zones, the current weather and wind station data. So this is a layer that is coming in from Living Atlas. So Living Atlas provides this wind station data for Pan India. So it is a live data that is being, it's a live service that is there in Living Atlas. This data captures the wind speed and also the location of the wind stations. And here we can see a beautiful cartography where we are showing the global average wind speeds based on the direction and based on its magnitude. Likewise, other layers are also taken in, most of them coming in from Living Atlas. And apart from these layers, there are also a few topographic layers like slope. So slope plays a crucial role while selecting a site for wind farms. So gentle slopes between 0 degrees and 6 degrees are ideal, right? And also the aspect should be west to southwest facing slopes. And once we have all this data, also the demography data, which shows the population density and the existing infrastructure data. Once we have all this data, we run the same tool that I showed on ArcGIS Pro. But here we are just showcasing the output and the input layers on a story map. So we are able to generate the suitable sites in green. And there are these different parameters and conditions that are met. So the district should be having a population of at least 1 lakh. Annual wind speed should be areas 10 meters off the ground. So these are all different parameters that are taken in from the inputs, and we get this output of the suitable sites for wind farms. ArcGIS Pro also provides tools to do micro sightings. So there should be a distance between the different assets that are there. There should be a safe distance between the assets. So these mensuration tools can be utilized to understand the geodesic distance in imperial units. So we can calculate the distance between different assets on the ground as well. Let's move on to real-time data integration. So I talked during the operation and maintenance phase, we'll be having different feeds coming in from different sensors. So this is the same area that I showed in the story map. So we have a live feed integration dashboard. We can see that there's a last updated refresh interval which is being currently shown. So we can see different indicators and elements used to detect whatever data is being captured. So the current electricity generation is at how much megawatts, the current weather parameters coming in from different weather sensors, the trend in energy of that particular day for both power and voltage, and also the weather parameters. So these kind of graphs help analysts as well as officers to understand if there are any anomalies happening on a day-to-day basis. We can also see SCADA entries, the total number of count, 60 SCADA entries are coming in from 60 sensors, and also the air quality monitoring parameters like the particulate matter 10, particulate matter 2.5, and temperature and humidity. Let's move on to the final demo for today. So till now we saw onshore assets. So this is a demo of an offshore wind farm, and this kind of renewable energy is slowly picking up pace. And this is experience build application that has been built with ArcGIS Velocity in the backend. So ArcGIS Velocity is an offering from Esri, which enables you to ingest live feed data up to 10,000 events per second. So here we have different parameters being captured from individual wind turbines. So the active power in kilowatts, rotor rotation per minute, wind direction, yaw direction, air temperature, and also the trend chart of power output. So this is the cumulative value that is currently shown here for all the different assets that are there. We can individually see for individual wind turbines as well based on the asset ID or asset name. And also this shows on the map through the symbology, we are able to see the red ones are currently offline, and the number of online devices, online wind turbines are 98. We can also set alarms based on threshold values. So if a particular value goes below a threshold, we can trigger alarms as well in this. So apart from the sensor integration, we also have weather API integration. So using weather APIs, we are able to plot the lightning strikes that are happening around this wind farm. So we can see there are 5 different lightnings that have occurred within 10 kilometers of our assets. And the list of the lightning events are also mentioned based on the duration in millisecond intensity and also the distance from the asset and date and time. And if it falls at a particular buffer, we can also tag it as a risk to that potential asset, and we can send maintenance teams for inspection. There is also collision monitoring which is happening here. So this is a collision monitoring module where we have the live vessel tracking system feeds that are plotted on the map. So the vessels are symbolized based on its type, whether it's a passenger or whether it's a cargo. And also there is a geofence, a dynamic geofence. So geofencing is done on a dynamic scale here, and it shows the 500-meter buffer around that particular vessel, and if it comes close to an asset, it will capture the total duration which it took inside that 500-meter zone. And also we can trigger alarms using webhooks, so the office staff can get triggers that there's an imminent collision that can happen. So we saw many interesting demos, we saw many interesting workflows. So now this is advantage to the people who are attending this webinar. We are just showcasing few resources that can be utilized by you to kickstart your project, or if you want to do some R&D on renewable energy. So first is ArcGIS solutions. So currently whoever who has access to an ArcGIS Online or ArcGIS Enterprise, they can directly access these solutions from this application launcher. And once you're inside it, you can see there are 150 solutions that are currently there. I will just filter it out for renewables. we can see there are different solutions. So what is a solution? So solution is a combination of multiple applications and multiple layers which SV curates. So these are ready-made application templates which comes with style packages, desktop styles, web maps, web scenes. So these will be the final output which I showcase now, like similar to that. So all you have to do is change the data in the backend, and you can utilize, these are all configurable templates, so you can utilize the current look and feel of what the application is, and you can change the data so that it matches to your particular area of interest. We also have courses in learn.arcgis. So you can go through the different courses as well. So I will just explain about this one in particular. So this is the same workflow which I use to calculate the solar potential for the city, rooftop solar potential for city in India. So this is a 1 hour 20-minute tutorial which gives you ArcGIS Pro project along with the datasets, relevant datasets, so you can get your hands dirty. It's a step-by-step tutorial, and it will explain you from start to finish how you have to calculate it and how you can utilize these layers. So till now we saw, sorry. So till now we saw, sorry for that. So till now we saw what kind of applications can be built, different kind of real-time integrations by bringing in data that used to be in silos, right? And also different use cases like site suitability, your 3D analysis, and all of that. So we saw many enterprise applications. We saw ArcGIS Pro and also the many enterprise applications. So we will see now how we can utilize ArcGIS Pro on enterprise. So the applications that I built were on ArcGIS Enterprise, and now we'll move on to see how you can efficiently deploy and manage these ArcGIS Enterprise on a cloud. So to tell you more about our cloud offerings and managed services, I would like to invite my colleague Ujjwal. Over to you, Ujjwal.
Thank you, Suraj. Those were some great insights. So following the PCL's team's compelling demonstration, I am delighted to share how managed services provides you with practical, highly impactable solutions to optimize your renewable energy projects. So let's dive into how our geospatial expertise and cloud-powered tools can make your work easier, more efficient, and secure. So renewable energy projects rely largely on complex spatial datasets required for planning, monitoring, and even managing of these projects. So we are here to help you meet your renewable energy goals by providing you with the right infrastructure and support. For example, if you're planning for a new solar farm in a remote region, you'll be working with some massive datasets. So this calls for a reliable environment with upscaling option available so that the infrastructure grows along with you. So this is where we are coming in to support your projects by taking in some strict security measures so that you can confidently scale operations, meet regulations, and also accelerate your clean energy goals. With this, you also have so many cloud platforms to choose from based on your business requirements. We'll talk about the available options in a minute. Let's just first quickly take a glance at what is Astro India's managed service. We provide you with some basic but crucial benefits to make your task easier. Like the infrastructure management, we handle the whole info for you, from servers to the underlying virtual machines and even OS patching, ensuring optimal performance for large-scale projects. Be it site planning or environmental monitoring, we have got you covered with the right infrastructure. We'll be taking care of your apps, enterprise deployment, migration, be it from premises to cloud or cloud to cloud, and even taking care of your backups, minimizing downtime and ensuring that your systems are running smoothly. Since your data is of the utmost priority to us, we'll make sure to take all the steps to keep it secure, keeping in check for your environment's health and sanity on a regular intervals, and also providing you with the VAPT from the third parties to keep in check for the vulnerabilities. We offer some decent SLAs based on the business continuity requirements, where the standard is the 8x5. However, for the customers who have some crucial business needs, the customization option is also open to them. Whether you're expanding your solar farms or integrating new wind energy sites, our cloud-based solutions scale dynamically, saving your time and resources. So coming back to the options I was talking about earlier, so we support most of the cloud services to ease the compatibility issues for various customers, like the Amazon Web Services, Microsoft Azure, Google Cloud Platform, and also to strengthen the trust of our Indian customers and to encourage the Make in India initiative, we're also supporting RailTel and GeoJob cloud services. All the cloud platforms we support are approved by METI, meeting government security and data security protection standards. This ensures our solutions are fully compliant and ready to use even in some critical public sector environments. So as mentioned so far, we offer end-to-end application support designed with SG security best practices. Our solutions include architectural design for scalability, high availability, disaster recovery, you name it, we have it. Although these services are divided into two levels, the components that you see here in the green on the left-hand side of the slide are part of our standard support package, which is included by default for all the new customers onboarding with us. This covers the essential services, including help desk support, OS and application levels of patching, regular backups, and recovery. Let's assume that you are already a cloud user, and in case something goes wrong, like a system crash or accidental data deletion or even a regional outage, our backup and recovery systems are in place to deal with your situations. As part of a standard support and industry standards, we offer reliable recovery point objective RPO and recovery time objective, that is RTO, where RPO is the maximum time between the last backup and the failure, defining the acceptable data loss. Meanwhile, the RTO is the maximum acceptable downtime before the system recovery. And if you still need a stronger shield of protection, we offer advanced options storing backups across different seismic zones and setting up automatic failover systems for minimal downtime. Bringing us to the points of the items listed in the red. These make up our advanced support offerings available as add-ons for customers who require enhanced capabilities beyond the standard scope. These services include architectural design tailored to our environment and business needs, capacity planning for future growth, cloud migration strategies, disaster recovery planning, etc. So these can be selectively added based on your requirements and are priced separately. So these services ensure that operations are running smoothly from the first day itself. And now that we have gone through various components, let's also see the values that we offer here at S3 India. So a team comprises of S3 certified and cloud certified professionals. Our solutions are designed to scale easily so they can handle the growing workloads or even adapt to the changing business needs without any disruptions. So as mentioned earlier, we are also proactively monitoring and maintaining the systems to ensure high performance, minimal downtime, and reliable operations. Our support team is available around the clock to ensure continuous service and quick resolution in case of any issue faced by the customer. We ensure fully automated backups at both infrastructure and application levels. And with our service, you gain a reliable partner to streamline your energy projects from planning to execution. With this, we aim to support initiatives like the one showcased today, where advanced technology and reliable cloud management come together to drive a real change here on the ground. We are here to support your journey towards a cleaner, smarter energy future.